Hi, in this video, we shall study the we shall test the convergence or divergence of a series using the nth term test. Right. Now, suppose we have a series uh, given by, let's say, n square. We have a series whose nth term. We have a series whose nth term an is given by n square plus 3n plus 1 upon 2n square plus 4. Now an is the nth term of the series. Now the series will be sigma an I equal to 1 to infinity. Now we want to see whether this series is convergent or divergent. Okay, is this series convergent or divergent? Now we do what is called the nth term test. Now what is the nth term test? The nth term test simply says that we check the limit an as n tends to infinity. Alright. So we check this limit an as n tends to infinity. Now if this limit is equal to 0, then the series may be convergent or divergent. So if this limit an as n tends to infinity is 0, then we don't know, we cannot be sure. Okay, the series may be convergent or it may be divergent. However, if this limit is not equal to 0, if it is not equal to 0, then we are 100% sure that the series is divergent. Okay, we are 100% sure. So, in the previous example, our an was equal to n square plus 3n plus 1 upon 2n square plus 4. Right. Now limit an limit an, which is n square plus 3n plus 1 upon 2n square plus 4. Now how much is this limit? We don't know. So we divide the numerator and the denominator by n square. So we get n square limit n tends to infinity. We get n square plus 3n upon n square divided by 2n square plus 4 upon n square. So that will be limit 1 plus 3 upon n 1 upon n square upon 2 plus 4 upon n square. Now, as n tends to infinity, this 3 upon n, 1 upon n square, 4 upon n square will all tend to 0. So this will be one plus 0 plus 0 upon 2 plus 0. That's equal to half. Now limit a n tends to infinity is half. Okay. Now this half, now we know it is not equal to 0. Therefore we can say that the series n square plus 3n plus 1 upon 4n upon 2n square plus 4 is divergent. So, if limit a n as n tends to infinity is not equal to 0, then we are very sure that this series is divergent. However, if limit a n as n tends to 0 is equal to 0, then we do not know. Then it may be convergent, it may be divergent. We have to do further tests. Yeah? So here we will have to carry out further tests. Do further tests. Okay.